particle moves in a straight line such that after t seconds its displacement x meters from the origin is given by this expression. We want to determine where the particle is initially. So that's just when t is 0, and we can see that that gives us 1. That means 1 meter to the right, because it's a positive 1, of the origin. The distance travelled by the particle in the first second. So that's t equals 0 to t equals 1. We have to be really careful here. It's tempting just to work out t equals 1 and then see the difference between the two. But that doesn't work if the particle turns around at some stage. So since we have the CAS available to us, why don't we actually graph this function? So let's just clear anything we've got, and we've gone back to a standard window, which is probably good. And so didn't seem to clear the function. Never mind, let's just get rid of it. So we have got 3x squared over 4. Take away 6, sorry, that one's to the power 4. 3x to the 4. So then we've got 6x, this one is squared, over 2. And then we've got plus 3x plus 1. Okay, let's graph that. So we're starting here at t equals 0, but it'd be nice to know what happens just here. Let's zoom in a little bit so we can see it better. So let's go, say, 0 to 6 here. And let's make it 0 to 3. And the y's, let's go -1 to maybe 9 or something. So it does seem to turn in that first second. So we'd need to know where this max is. So analysis gsolve and the max. So it's the y we're interested in, that's the distance, and that's this number just here. So 1.8176. So it goes from its initial position of 1 out to 1.8176. And then let's do a ycal when x is equal to 1. So that's t is 1 second. See where it is there. So 1.75. So it's going to then go 1.8176 to 1.75. So our distance travelled is 0.8176 plus, we just go to main, we do 1.8176, take away the 1.75, 0.0676. So that is going to be, so we'll do that added to 0.8176. I'm going to put this as 0.89 meters to 2 decimal places. We now want an expression for the velocity, so we need to differentiate. So that's going to be 12 t cubed over 4. Take away 12t over 2 plus 3. So that gives us 3t cubed minus 6t plus 3. Now let's just get rid of the scribblings from that other question. When the particle is at rest, so this means that v equals 0, so we've got 3t cubed minus 6t plus 3 equals 0. So let's solve that. Fraction, advanced, solve. So we've got 3x cubed minus 6x add 3 is equal to 0. And obviously the negative value, t starts at 0, so the negative value is no good. But we've got one solution here, which is t is 1, and there's one just off here, which seems to be at 0.62, so t, I'm going to call it 0.618, keep an extra decimal place there. Finally, we want the acceleration when the particle is at rest. So to get acceleration, we differentiate this one again, so that's going to give us 9t squared minus 6. So a of 1 is just going to be 3 meters per second squared, and a of 0.618 is going to be 9 multiplied by 0.618 squared, take away 6. And that's negative 2.56 meters per second squared. And again, I've given that to 2 decimal places.